So, Assalamualaikum and good morning to everyone. So, I'll be introduce all my group members with their name and their matric number. So, first one is me, Izul Husaini bin Muhammad Zaidi, holding matric number of 08DJK22F1002. My second group member is Muhammad Firdaus bin Abdul Talib, holding matric number of 08DJK22F1026. Third group member is Irfan Izzuddin bin Zulkifli, holding matric number of 08DJK22F1019. And lastly, my group member is Muhammad Aidil Satria bin Azmi, holding matric number of 08DJK22F1059. So, I hope everyone will enjoy the video that me and my friends has recorded, and that's all from me. We're moving to the next slide. Hope you guys enjoy.
Introduction to integration. Integration is introduced as the reverse process to differentiation. It has wide applications, for example, in finding areas under curves and volume of solids. And then in previous chapter, we find derivative of function by using the concept of differentiation. Therefore, this chapter we shall learn how to recover the differentiation coefficient of the functions. In other words, we can say that integration of a function is to get original version of the function fx from its derivative fx.
So, hi, my name is Izul Husaini, matric number 08DJK22F1002. So, I'll be explaining a little bit about chapter 3.8, which is application of integration to find area. So, as we all know, integration is used to find area. For example, a civil engineer might want to know the area of a piece of wood used to do formwork, which is to build an arc for building. So, as we all know, architect or people in construction field, they usually need this thing, which is important thing, to make sure the thing that they build or that they planning to do is on their track and follow the SOP, uh, which will did not harm other people. If so, let's say if there are any mistake that they do, maybe they will harm other people, maybe the building will collapse or anything. So next, a fashion designer, they want to know the total area of the fabric needed to make a curtain. So moving to the diagram, so we can see the diagram. Positive will be on the top of the x-axis and negative will be on the bottom of the x-axis. So that's all from me. We're moving to the next slide, which is the question. Okay, that's all from me. Thank you. So, hi, my name is Izul Huzaimi. So we're moving to the first question. So we can see the first. So first we can see the diagram. So we can see there's two different shaded region, which is on the top of x-axis and on the bottom of the y-axis. So there are two different shaded region. So first one is integrate 1 to 2 y dx, and second one is integrate 2 to 3 y dx. So first step for the first shaded region, integrate 1 to 2 y dx. So we will start with integrate 1 to 2 in bracket x to the power of 3 minus 6x squared plus 8x close bracket dx. Second step, we will need to do open bracket. So x just now, we must add another one, x raised to the power of 4 over 4 minus 6x raised to the power of 3 over 3 plus 8x square over 2 close bracket. Then we put the integrate just now at the end of this bracket 1 to 2. So another step, which is we put a big bracket 2 raised to the power of 4 over 4 minus 2 bracket 2 raised to the power of 3 plus 4 bracket 2 to the power of square close bracket minus with 1 to the power of 4 over 4 minus 2 times 1 to the power of 3 plus 4 bracket 1 power of 2 close bracket. So the answer for this shaded region is 4 minus 9 over 4, which will be 7 over 4. So next will be the another shaded region. So integrate 2 to 3 y dx. So integrate 2 to 3y dx. For the first step, we need to do integrate 2 to 3 open bracket x power of 3 minus 6x plus 8x close bracket dx, and move to the next step. Open bracket x power of 4 over 4 minus 6x power of 3 over 3 plus 8x squared over 2. Then we need to close the bracket. So we just the same like the first shaded region step. So we put the integrate just now at the end of the bracket, so 2 to 3. Then we move to the next step. So open big bracket 3 raised to the power of 4 over 4 minus 2 close bracket 3 to the power of 2 plus 4 excuse me, just now is 2 bracket 3 to the power of 3 plus 4 3 to the power of 2 close bracket minus open bracket 2 to the power of 4 over 4 minus 2 bracket 2 power of 3 plus 4 times 2 power of 2. So close bracket. So the answer will be 9 over 4 minus 4 equals to negative 7 over 4. So we make it positive, which is 7 over 4. So so the final answer will be 7 over 4 plus 7 over 4. So which the answer will be 7 over 2. So that's all from me. So we're moving to the next question. Thank you.
Hi, my name is Muhammad Aidil Satria bin Azmi. My metric number is 08DJK22F1059. Question 2. So we can see the graph like S shape. X is equal to y in bracket y minus 1 and in bracket y minus 2. So the limit of shade region when x is equal to 0 in bracket y minus 1 and y minus 2. So y is equal to 0 and y is equal to 1, and the last y is equal to 2. And we got the solution. Shaded area is located below two different regions. Thus, integrate 0 to 1 x dy. Integrate 0 to 1 y minus y in bracket y minus 1 and in bracket y minus 2 dy. So the answer, integrate 0 to 1 in bracket y power of 3 minus 3y square plus 2y dy, and in bracket y power of 4 per 4 minus 3y power of 3 per 3 plus 2y square per 2 in bracket integrate 0 to 1, and then in bracket 1 power of 4 per 4 minus in bracket 1 power of 3 plus in bracket 1 square minus in bracket 0. So the next answer 1 per 4 minus answer, and we got 1 per 4. The next step is integrate 122 x dy. Integrate 122y in bracket y minus 1 and in bracket y minus 2 dy. And we got integrate 122 in bracket y power of 3 minus 3y square plus 2y dy. And the next in bracket y power of 4 per 4 minus 3y power of 3 per 3 plus 2y square per 2. Integrate 1 to 2. And then in bracket 2 power of 4 per 4 minus 2 power of 3 plus 2 square minus in bracket 1 power of 4 per 4 minus 1 power of 3 plus 1 square. So we got 0 minus 1 per 4 and the last answer is negative 1 per 4 in positive 1 per 4. So the real answer is 1 per 4 plus 1 per 4. We got 1 per 2 unit square. Okay, thank you.
Hello and good morning. My name is Muhammad Firdaus bin Abdul Talib. My matrix number is 08DJK22F1026. Okay, my topics that I got for this presentation is 3.9 application of integration to find a value. Okay, for certain object, we already know how to find a value by using their suitable formula. We know how to find the volume of the cylinder, the cone shape, the half sphere, even the volume of the vase. Okay. In this topic, we will find a rotating structure volume by using integration. So, the volume generated in the integration, the overall we use is integrate 0 to A. A is whatever number on the volume that we want to find. Pi y square dx. Okay, moving on. Okay. So the question that we got to find the value using the integration is based on the graph that we see. The line, the equation is 2y per x squared, and to find the volume within the 1 to 2. So the volume generated in this graph is integrate 1 to 2 pi y squared dx. Okay, so first thing we do is to find the y. So we got the y is y equal to x squared per 2. So we put the y we got into the equation that volume generated. So we got integrate 1 to 2 pi bracket x squared per 2 bracket square dx. So we see that x2 per 2 bracket square, we can expand it. So we got x4 per 4. So we put it on the equation, and then it goes like integrate 1 to 2 pi dot x4 per 4 dx. Okay, so after that we move beside x to the in front of the integrate. So the equation goes pi per 4 integrate 1 to 2 x4 dx. Okay, so we see the x. So after that we integrate the x4. Sorry. So this goes x pi per 5. So after we integrate it, we can solve by using the integrate 1 to 2. So the equation goes pi per 4 bracket x pi per 5 in bracket 1 to 2. So we substitute the x to 1 and 2, the bigger number, minus the the small number. Okay, sorry. So the equation goes to 5 per 4 dot in bracket 2 5 per 5 minus 1 5 per 5. So first thing we solve in the bracket first, and then we got 31 per 5. So the 31 and 5 multiply the pi per 4. So you got 31 pi per 20 unit cube. That's all. Thank you.
Okay, the question is about to find the shaded area, which is I put the shaded area as A. Okay, there's a equation in the picture, which is after we solve the equation, we will get 4x squared over 2 minus x power of 3 over 3 min in minus 2x squared over 2, and then if we solve the equation, we will get 2 times 2 square minus 2 power of 3 over 3 minus 2 square, and then the answer is 8 minus 8 over 3 minus 4, and then the last answer we will get the 4 over 3 unit square. Okay, this one is the conclusion. To sum it all, integration is not simple thing to learn. It requires us to have a very deep understanding in this topic and able to solve and understand the problem. This topic also is an important topic in engineering field. It commonly used in civil engineering sector that require many things from this topic to make sure everything works well and no mistake occur while their work or project in progress. Okay, like for me, this integration subtopic, we must give a full attention because I think it's a bit harder if you don't give a full attention to this subtopic.